guys, back for the calculated portion of the test. So here we got a picture of f prime. F is continuous on closed interval, and then it says the derivative of f is shown above, which following, whereas f increasing, f's increasing when this is positive, so 0 to 2, 4 to 5. Really, it shouldn't be, they should be open intervals, but they always do that. Not really sure why. Says the height of an object is given right here. What is the velocity at t equals 3? Now you can take the derivative, but you don't have to. You can go to your calculator and you can plug this function in. So we get x squared minus 16 divided by x plus 15. We'll go to a normal viewing window. And if we're interested in the velocity at time 3, then we're interested in, oops, I had two functions, sorry. So x squared minus 16 divided by x plus 15. So we hit second calculate. We're interested in the derivative. And then when it asks me for the value, I say when t equals 3. And I get 7.778, so answer B. Okay, the function f says we have a differentiable and has a point, -1, 4, and a slope of 2 at that point. What is the approximation of g of -1.2 using a tangent line? So anytime I see tangent line, I just tell myself I need a point, I need a slope. So the point is -1, 4, and the slope is 2. So my equation is y minus 4 equals 2 times x plus 1. I'm going to solve for y, but just by adding across there. So I have 2 times x plus 1 plus 4. And I'm interested in this is very close to the function, as long as we are close to y equal, or x equals -1. So we're going to plug in a -1.2. So I get 2 times -0.2 plus 4, so I get -0.4 plus 4, which would be 3.6, so we get A. You are welcome to use a calculator on that if you need it. 79 says, Tara's heart rate during a workout is modeled by the differential equation H in beats per minute. So H is her heart rate in beats per minute. And it says, which of the following expression gives the average rate, Tara's average heart rate? So if you want the average value of a function you've been given, then you just do integral divided by interval. So that would be this one, not of the derivative, just of the function. If you're given a function and you want the average of its of its derivative, then you would do average slope. Next one says, here is g prime. And then we know g of 2 equals -7, and we would like to know what g of 5 is. So I'm going to do the integral of x cubed plus x from 2 to 5. That's g prime in there. So the fundamental theorem says g of 5 minus g of 2 comes out. Well, g of 2 is -7, so we'll say plus 7. So I just need to get this, and then I'm going to subtract 7 from it. So I'm going to go to my calculator, and I'm going to plug in the square root of x to the third plus x. I'm going to hit second calculate, 7. Again, don't think just because I can do this that you can do this. Make sure you are using your calculator, even if it's not going to be on the test. We take that and then we subtract 7, so we've got 13.899. Okay, try to get a couple more in here. This function has a removable discontinuity. The only type of removable discontinuity is a hole, so that would be C. All the rest jump, asymptote, non-removable. Removable means with one change of a point, we could make the function continuous. Okay, so here we have the integral from 0 to 17 of fx equals 8, from 17 to 20 equals -3, from 13 to 20 equals 7. What's the value of 0 to 13? So this takes me all the way from 0 to 20. So I would take the 8 plus the -3. That would take me from 0 to 20. And then I would have to get rid of the 7 because I want to know what's happening from 0 to 13. So this is from 13 to 20. So 0 to 20 minus 13 to 20. So minus 7. So I would get what? -2. So I'd get A there. All right, I'll be back for 83 here in a minute.